So number 4, we're trying to prove that the diagonals of an isosceles trapezoid are congruent. Okay, so our first job is to draw the figure on this coordinate plane, labeling the vertices with variables. So first of all, what shape are we going to draw on here? An isosceles trapezoid, right? Okay, so we have a couple of choices. We could put a vertice or a vertex right on the 0, 0 mark. We could move it over so that it's overlapping a little bit into the negatives of this coordinate plane. Or we could make the trapezoid so that it is being bisected by this, don't draw this yet, bisected by the y-axis, like that, or like that, or like this. Okay. In some cases, some things are easier than others. For me personally, I like to always put one of the vertices on 0, 0. It's just me. You could move it over. You could bisect it with the y-axis, but I'm going to go with this for now. Okay. Now, what we need to do is establish what the coordinates will be of these vertices. Let's label them first. Now, the important thing to notice here is that this distance has to be the same as that distance. If it's not the same, then you don't have an isosceles trapezoid, which is an important point to make here, because if you don't need an isosceles trapezoid, if it just says trapezoid, you have to make sure that those two segments are not the same, so that you're finding the general case. But in this case, we have an isosceles trapezoid. So we're going to make those two the same. So I recommend kind of establishing what the distances are going to be first. What do you want to call that green distance there? What should we call that? A? You want to call it A? All right, let's call it A. So those are both A. Maybe we'll make this distance between them B. And then what should the height of this trapezoid be then? Let's call it C. All right, then, what would be the coordinates of B? Yeah, AC over A, right? This distance A, up C, AC. What would the coordinates of C be? Yep. A plus B, comma C. Good. And what about D? Yep. 2A plus B, 0. Okay, so you can see that no matter how you position it, whether you have a point on the origin or not, if you establish the distances, that will dictate what your coordinates will be. Okay? All right, now we have to prove that the diagonals of an isosceles trapezoid are congruent. Which formula are we going to use? Diagonals are congruent. Distance, right? Okay, so we are going to use distance formula. I want to establish that that's what we're using. And we're going to find the length of what segments? Yep. BD and CA. Well, the distance formula says subtract the x's and square it. All right, well, BD, A and 2A plus B. I think I'm going to start with my 2A plus B and subtract A. 2A plus B minus A squared plus, now I'm going to subtract my y's. So I'm going to start with 0 minus C squared. And then I can simplify. 2A minus A is just A plus B squared plus, and this is negative C squared is just C squared. And we still have the square root sign over it. Now, if we were going to simplify this further, if we were going to multiply it out, remember, what is A plus B, in parentheses, squared? Raise your hand. What is it? Yep. Yes. Which is then what? So it's A plus B times A plus B. So it's A squared plus 2AB plus B squared plus C squared. Do the squareds and the square roots cancel out? Nope. Remember last week? Nope, nope, nope. You cannot take the square root of any of these individual pieces because you are taking the square root of the entire sum. And we don't know the square root of that entire sum. And you can't take them individually. Okay, so that's a little messy, but luckily all we have to do is show that this is going to come out to be the same. If CA looks the same, then we're good. So CA, we're going to, again, subtract the x's. So we got A plus B minus 0 squared plus C minus 0 squared. And again, we have A plus B squared plus C squared. Now, we probably could have left it in that form and been able to compare and know that they were going to be the same. But I wanted to remind you of that fact that A plus B, this quantity squared, is not just A squared plus B squared, and it's not something that you can take the square root and simplify. This has to remain exactly in this form. That is as simple as it can go. But this is exactly equal to that. So you might want to make a little note of that. BD equals CA. And then since this is a proof, you always want to end with your proof, right? You want to end with what you're trying to prove. So your conclusion would be, since BD equals CA, then the, and then you're just going to copy this, diagonals of an isosceles triangle, trapezoid, isosceles trapezoid are congruent. Okay, let's read number 5. The segments joining the midpoints of the sides of an isosceles triangle forms another isosceles triangle. The segments joining the midpoints of the sides of an isosceles triangle forms another isosceles triangle. What is the first shape that we need to draw on this ordered, this coordinate plane? What do we need to draw? What do we have to start with? An isosceles triangle. Now, this is one where I do like to straddle the y-axis. We could do it either way, but let's show an example of straddling the y-axis. Okay, since it's isosceles, I know I need to go the same distance to the left as I do to the right. So what should we call that distance? Okay, Henry? Okay, I'm glad you said 2a. I'll be honest with you, my first thought process is always A, B, right? Okay, you were going to say the whole thing. Okay. So he was going to say this whole thing is 2a. So each of these is a. But I'm still going to propose the fact that if you know you're finding midpoints, double everything. Double everything, because it will make your midpoint formula easier. So instead of this being 2a, let's make it 4a, which makes each of these 2a. Which makes the coordinates of a would be what? 2a, 0. What are the coordinates of c? Good, negative 2a, 0. And what about b? What should we make that one? 0, comma, up, b, but remember double everything. So let's make it 2b. If you know you're finding midpoints, if you double everything that you first think of, it usually works out better. Okay, now the three segments joining the midpoints of the sides. So what's the first thing we need to do? What formula should we use first? Which formula should we use first? What do we have to find here? A lot of dead space on this recording here. Come on, Sam. Midpoints. We need the midpoints of the three sides. We have to find those using midpoint formula. Midpoints of the sides, what we need first. So we need the midpoint of AB. We need the midpoint of BC. And we need the midpoint of AC. I'm going to say let's name these different letters now. Let's call it X, Y, and Z, those midpoints. So the midpoint of AB is X, and the midpoint of BC is Y, and the midpoint of AC is Z. All right, well, to find the midpoint, we are going to add the x's and divide by 2. So the midpoint of AB, we're going to add 2a plus 0 over 2, and 0 plus 2b, which is just 2b over 2. See how those doubling everything makes this nice and easy? That's an AB. The midpoint of BC, we're going to add the x's again, 0 and negative 2a, which is just negative 2a over 2. And then 2b and 0 is just 2b. And that's going to be negative ab. And the midpoint of AC, if we add 2a and negative 2a, we get 0. If we add 0 and 0, we get 0. And z is just going to be the origin, 0, 0. All right, so we found the midpoints of the sides. We're trying to prove that this blue triangle here, XYZ, is another isosceles triangle. What formula are we going to use to prove that this is an isosceles triangle? Distance formula. So now we need to find the length of each side of XYZ. So we're going to find the length of XY, the length of YZ, and the length of XZ. Distance formula. XY, that's here to here. So we're going to do subtract the x's, a minus a negative a, which is plus a positive, right? And subtract the y's, b minus b. Well, a minus a negative a is a plus a. What's that? 2a squared plus, this is just 0. What's 2a squared? 4a squared, right? Because 2a times 2a is 4a squared. And the square root of that is just 2a. Since that's just one term, we can find the square root of that. There's no plus signs in there. Okay, yz, the square root of y to z, we're going to subtract the x's. We're just going to get negative a minus 0 squared plus b minus 0 squared. Negative a squared is a squared plus b squared. So far, do we have an isosceles triangle? Nope. Those two aren't the same. We got to find xz. Xz is going to be a minus 0 squared plus b minus 0 squared, and that's a squared plus b squared square root. Again, your final step here would be, since yz equals xz, then, and then you're going to copy what you're trying to prove. The three segments joining the midpoints of the sides of an isosceles triangle forms another isosceles triangle. Oops. An isosceles triangle forms another isosceles triangle.